Well, this lesson is about unit vectors. A unit vector is just a vector with magnitude equal to 1. So a vector with length 1. Okay, so we've got two standard unit vectors. We've got the horizontal unit vector, which is vector I. And instead of putting the usual little arrow symbol over it to show that it is a vector, unit vectors have a special symbol. It's like a little hat, and that means it's a unit vector. So the horizontal unit vector is called I. So we are talking about a horizontal vector that has a magnitude of 1. And then there's the vertical unit vector. Whoops. The vertical unit vector is called J. So vertical unit vector J is going to be a vertical vector with magnitude 1. Now, any vector can be represented as the sum of unit vectors. For example, let's say if we have vector AB that goes from the point 4, -1 to the point 6, 2. The vector would look like this. Now, in component form, we would describe this vector and we would say the horizontal component is 2 and the vertical component is 3. From A to B, we're going right 2 and up 3, so we would go like this, 2, 3. That's component form. But instead, we could use unit vectors. We could say that we have 2 horizontal unit vectors and 3 vertical unit vectors. Okay, so this would be 2I, all right? I is the horizontal unit vector, and this would be 3J. So instead of using component form, we could write this as the sum of unit vectors I and J, and so we could write 2I plus 3J. And that would mean the same thing. That would be the same vector as the vector 2, 3. So of course we don't need a picture for this. In general, we can always write the component form by doing x2 minus x1 and y2 minus y1. So we could simply go 6 minus 4, that's 2. And 2 minus -1, which would be 2 plus 1, which would be 3. So then we've got the component form. And from there, switching this to the sum of unit vectors, 2I plus 3J is a trivial matter. So for this example, we are supposed to find the magnitude, and we're also supposed to write the vector as the sum of unit vectors. Well, let's get that whole sum of unit vector part out of the way. If this if this is the component form, the unit vector form would be 8I minus 6J. All right, could not be easier. Notice if it's negative, just write it as subtraction. Then the magnitude, we learned how to do that a long time ago. We just do the square root of 8 squared plus -6 squared. So that's going to be the square root of 64 plus 36. So that's going to be the square root of 100. So that is going to be 10. Okay, example 3. I guess we're using the same directions still. So in unit vector form, this would be negative 7I minus 5j. Okay, that's all there is to that. And then the good old magnitude, we do negative 7 squared plus negative 5 squared. So that's going to be the square root of 49 plus 25. So that's going to be the square root of 74. Okay, for example 4, we are given these two vectors, u and vector v. And so now we're going to do some operations. So vector u plus v, using our unit vector form, I'm going to have negative 3i plus 8j, and then plus vector v, which is 2i minus j. By the way, if you're wondering why, when you're looking at the directions, they just use u and I and j like this. You know, they have I and j with just dots above them, whereas I'm using these little vector hats. So why am I using vector hats when in the directions they're not using vector hats, they're just using normal letters? The reason is, in type, you can indicate that something is a vector by making it bold. So this is not just a U, it is a bold U. This I and J, they are bold. That means that they are vectors. When we're writing by hand, we can't write bold and not bold. So we need the symbols. Like if I write U, I have to put this over it to say that it's a vector. If I write I got to put the hat, or J, because these are unit vectors, get the hat. Alright, but that's why I'm using the little symbols, whereas in the directions the symbols are not used. Anyway, back to doing the problem. We're just going to combine the corresponding components. So negative 3i and positive 2i, that's negative I. 8j minus j is 7j. Okay, this is almost insultingly easy. Alright, example 5 is still referring to the vectors we were given, but I cannot hold vectors in my head like that. So I'm going to have to look back because I have zero memory. I feel like there are literally mice that have more memory than I do. So negative 3i plus 8j. And then vector v was 2i minus j. Okay, so I'm just going to do the distributive property. Let me mention one thing though. Whenever I subtract, I always add the opposite. I put a little plus sign here to remind me that I'm really going to distribute negative 3. I'm not going to distribute 3, I'm going to distribute negative 3. So you do the same. So with that in mind, I'm going to have negative 6i plus 16j, and then negative 3 times 2 will give me negative 6i. Alright, so I can go ahead and I don't need the plus anymore. I'll just put minus 6i. Negative 3 times negative j is going to be positive 3j. And now I could just combine like components. So negative 6i and another negative 6i is going to be negative 12i. And let's see. 16j plus 3j is going to be plus 19j. Alright, and that is it for example 5. Alright guys, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.